안녕하세요. I cannot speak Korean, so I have to use English, sorry. My name is Geng from POSTECH, and my talk is an abrupt ENSO-North Atlantic teleconnection reversal in early January. And this work is jointly contributed by myself and Professor Geoscience. My report includes 4 main parts, and first I want to do some brief introduction. ENSO teleconnection in North Atlantic region is a long-lasting hot topic, and early studies argue that ENSO teleconnection in this region is quite weak and cannot be detected at all. But many subsequent studies argue that ENSO can extend its influence in this region, but this influence exhibits highly asymmetric and non-stationary features. For example, ENSO influence is in the early winter is opposite to those in the late winter. This is our new early winter, November, December. We can see that in North Atlantic region, north is a negative anomaly and south is a positive anomaly. That is a typical positive annual response. In the late winter, January, February, it is suddenly replaced by a negative annual response. Actually, this different annual response during early and late winter is firstly identified in 2003. So it's a node of new finding, and many mechanisms have been proposed to explain this different annual response. But most of them concentrated on neither the early winter positive response or the late winter negative response. Several of them focused on the transition itself. So up to now, we still don't know how and when this annual phase reversal occurs. And most importantly, which mechanism dominates this annual phase reversal is still an open question. So to answer this question, we conduct our analysis. We begin by showing the ENSO regressed daily SLP anomalies over the North Atlantic region. It is from December to January. We can see that in the beginning, from December the 1st to about January the 5th, North Atlantic region is featured by a typical positive annual phase. But from the January the 10th, it is suddenly abruptly replaced by a negative annual response. The green line shows the annual index. It also shows an abrupt transition. So this figure clearly shows that the annual phase reversal is kind of occurs of phase loss to the early of January. So this is quite an interesting phenomenon. Next, we show the SLP anomaly during the 2 super early winters, that is 97, 98, and 15, 16 super early winters. We can see the anomaly also shows the abrupt annual phase reversal in the early January. And also we employed 26 simulations from the CMAP6 and did a parallel analysis, and the results also show this annual reversal from positive to negative. And even the transition timing agrees perfectly with the observational results. In addition, after this annual phase reversal from positive to negative, that is from P1 to T2 period, we can also detect prominent climate response. This figure shows the temperature. We can see after this annual phase reversal, we can detect prominent warming in Eastern Canada and North Africa. But in Eastern America and Western Europe, it is abrupt temperature cooling. So actually, with this evidence, we can see this abrupt ENSO annual teleconnection reversal in early January is a physical, meaningful phenomenon, which is worthwhile for our careful attention. So next, I want to do some analysis to show what is the mechanism responsible for this transition. We first checked the stratospheric pathway, because previous studies usually consider the stratosphere as a main mechanism connecting the late winter response of NIO2 and so. But in our case, no signal can be detected in the stratosphere propagating downward to affect the stratospheric anomaly. So we think the stratosphere is not the key reason for this annual phase reversal. So next, we just focus on the tropospheric process. This figure shows the where potential height anomaly at the 250 hectopascal and the associated wave activity flux during the P1 and P2 period. We can see during the P1 period an evident erosive wave propagation from the tropical Pacific and with northeastward propagation direction to the North Atlantic region. Here is a negative anomaly near the Iceland, so project on the positive annual phase. But during the P2 period, the figure is quite similar with the P1, but the difference is in this black box region. And because in P1 period, the propagation direction is northeastward, but in P2 period, the propagation direction becomes southeastward. So this different propagation direction will make the negative anomaly shifting from the north to the south, just correspond to the annual phase reversal. So we think this direction change is the key reason. And this direction change can also be reproduced in the MX simulation. So the next question becomes why the wave activity flux direction changes in this P2 period. Because this change is mostly confined in the meridional component, so we just analyze this component. According to the formula, the meridional component Fy can be divided into 4 terms, and these terms, the latitudinal distribution of these terms are displayed in the figure for P1 and P2. We can see that both for P1 and P2, the meridional component Fy is mostly contributed by the term 1 and term 2. These are the 2 most largest terms. We analyze the expression for the P1 and the P2, and we recognize that this term actually reflects the anomaly spatial pattern of the stream function anomaly. If the stream function anomaly has the tilt of northwest, southeast direction of tilt, then we will have a positive term 1 and term 2. If the anomaly pattern have a northeast, southwest tilt, we will have a negative term 1 and term 2. And this inference can be confirmed by the real distribution. We can see that in P1, the stream function anomaly is indeed northeast, southwest tilt. But in P2, it is changed to the northeast, southwest tilt. So that leads to the different propagation direction. So the next question becomes why this anomaly pattern, the tilt direction have changed during these 2 periods. And we thought that it is because of the climatology change. And the upper left figure shows the climatology of lunar wind at upper troposphere. And the contrast shows the P1 climatology for the U wind. We can see evident Atlantic jet here, and to the north of the jet, the wind speed decreases with latitude. So the distribution is like that. In the south, about 40 degrees, the west light is stronger. And in the north, about 60 degrees, the west light is relatively weaker. So this distribution favors the anomaly to tilt like this way. Northwest, southeast tilt. But from P1 to P2, we can see the shading. The shading is the change. In the north, about 40 degrees, we can see the west light is strengthened. But in the south, about 40 degrees, the west light is decreased. So this will make the anomaly pattern shifting like this way. So we can get these different anomalies tilt direction. And we also define index use box A minus box B, and it's a green line here. The time evolution is displayed. We can see the time evolution matches very well with the meridional component of the wave activity flux Fy. And this relationship can also be quantitatively reproduced by the MF simulation. So up to now, we're quite clear why in P1 we can detect this negative anomaly in the north, why in P2 we can detect a negative anomaly in the south. But NAO itself is a dipole structure. How this positive anomaly here and here be generated? We thought that it's because of the North Atlantic intrinsic 80 low frequency low frequency feedback. This frequency feedback generally follows the left-hand row. That is because that is the 80 vorticity flags detected almost 90 degrees towards its left-hand row. So if we have an cyclic circulation, it's just a divergence. If a cyclic circulation is just a convergence. So let's see our results. During the P1 period, we have a negative anomaly here. So the vorticity flags convergence here. So this will individually introduce the divergence in the south. So the positive anomaly is generated. In P2, we have a negative anomaly in the south. So convergence to the south. This will individually lead to a divergence in the north. So the positive anomaly is generated. So we think that the 80 low frequency flow feedback works as an amplifier to facilitate and complete this dipole angle response. And so next I will give my main conclusion, just 3 points. The first one is during ENSO winter, we can detect early January, we can detect a positive, abrupt annual phase reversal from positive to negative. And this reversal is largely caused by ENSO-induced Rossby wave propagation direction change. And this change is governed by the local climatological alteration of the local jet meridional shear. And in addition, we think the North Atlantic intrinsic 80 low frequency flow feedback will play an amplifier to further facilitate and complete this dipole angle response. Here is my report. Thank you.
Thank you. Any question or comment?
Very nice job. So you focus on analyzing the ENSO and NAO.
Yes.
So I'm wondering whether you may have a similar result when you look at the ENSO and Arctic oscillation.
You mean the Arctic oscillation? I haven't tried, but I think we can detect similar results because NAO is generally recognized as a local manifestation of the AO. But I will try later. Thank you for your suggestion.
Okay, any other question? Yeah.
Thank you for the nice talk. Actually, we tackled a very similar problem with one of our previous researches. So in our research, during the P1, so the Rossby wave source over the Equatorial Pacific is directly generated the atmospheric teleconnection, which is projected to the positive NA. And then during the P2, so the ENSO generates the anti-warming, and the positive anti-warming can generate the tripolar pattern, which is projected onto the Earth, and negative NA also.
Yeah.
So you might want to cite for the
Yeah. Actually, we know that the tropical North Atlantic SST may play a modulation on the late winter negative angle response. So we analyzed the SST distribution in the North Atlantic region. Yeah, here is the P1 and P2. It's some different, but it looks similar. So may play some role, but I think it's not the most important role, I think. Yeah. But some difference indeed can be detected. Yeah.
So he already cited your paper.
Yeah.
Okay, any other question? Okay, thank you.
Yeah.